Hello students, in this video we'll begin our discussion on discounted cash flow analysis. What I need for this is I need an effective annual rate of interest or cost of capital. I need to be given a cost of capital in our parlance this is going to be effective annual rate of interest. So we'll call this cost of capital for the problem. We'll call this I for interest. All right. And what we're going to do is we're going to write down all of our cash inflows and cash outflows at different times. So we're going to consider times. This is time. And time is going to go between 0 and t capital. And I usually think of time as discrete. Like I think of time as 0, 1, 2, 3, 4. And that's usually the typical setup over here. Although we can do it monthly, quarterly, semi-annually, doesn't matter. Okay? And then we define the net present value. Define the net present value or NPV by the formula NPV as a function of I is going to be the sum. Little t goes from 0 up to t capital, and all of that means every bit of information you have, put that into your sum. The cash inflow at time t over 1 plus I to the power t, that gives me my present value factor, minus the sum t goes from 0 to t of the cash outflow at time t. All divided by 1 plus the cost of capital to the power t, that's a present value factor. Okay? So oftentimes what we do is instead of writing these double sums, we concatenate this as a single sum. I'm going to if we let delta t to be the cash inflow minus the cash outflow at time t. Then we can write the net present value I as just the sum. T goes from 0 to t capital of this delta at time t over 1 plus I to the power t. And so that gives us our net present value as a function of the cost of capital. So let me show you an example of this. So given a cost of capital example, given a cost of capital of 10%, that means my I is 0.1. And let's say that we have the following sort of scheduled payments. Let's say here's our time, and here's our cost, our delta t. So let's write that as delta t, our delta. Okay. We have time 0, 1, 2, 3, and 4. Let's say you make an investment of $10,000 at time 0. So you have negative 10,000. And then let's say you get a stream of payments $2,000 at time 1, so you make $2,000 in the first year. Then you make $6,000 in year 2. Then you make $3,000 in year 3. Then you make $1,000 in year 4. Okay? And so you can look at this and say, oh, well, I have 6,000, 3,000, 1,000, that's 10,000, extra 2,000. That seems like it's a good idea, right? Because I'm investing $10,000 and I'm getting a total of what? Let's see, 8,000, then I go from 8,000 to 11, 11 to 12. So I'm making $12,000. The issue is that $1,000 that you're making has to be brought back to the present time. This 3,000 that you made in year 3 has to be brought back to the present time. You have to equate all of these values at the present value. That's why it's called a net present value. You're taking all of your future earnings, bringing them back to time 0, and comparing what you actually expect to get at the initial time at time 0 to see what the cost of capital is. So what would the net present value of this stream be over here? So the net present value, let's write it down. NPV would be negative 10,000. Because the t is equal to 0 here, so anything to the 0 power is equal to 1. Then it'd be what? Then it's going to be, that's a negative, that's going to be 2,000 over 1.1 to the first power, plus 6,000 over 1 plus 1, 1.1 squared, plus what? The next thing we're going to add on is going to be a 3,000 over 1 plus I cubed. And then plus, the last one is 1,000 over 1 plus I to the fourth power, okay? So we have those streams of payments over there, so that's exactly what we have. Now notice there are different numbers. So if you plug this into the calculator, what you're going to see is this. You're going to see for this example, the net present value is negative 280, approximately negative 286. Now that tells you at this rate, at this cost of capital, this capital project is not worth investing in because the net present value is negative. So when you compute the net present value and you assign yourself a basis of a cost of capital, if the net present value is negative, that implies that the project is not worth pursuing. If the net present value is positive, it implies that it is worth pursuing. This, of course, is assuming that the cost of capital is fixed throughout the duration of the project, which is not in general true. And it also assumes that we're not accounting for inflation in this project. So in further videos, we'll investigate how inflation and how random interest rates or random costs of capital affect the net present value. And this will no longer be a deterministic thing, but rather it'll be a probabilistic thing. And we'll have to estimate the expected value, the variance, the standard deviation of these net present values to do analysis on these capital projects. Thank you very much.